So?
No, not this one.
What you should try to find is here where you search, you write map.
It's a shortcut of the list.
Ah, there it is. And now you like this. There was a shortcut there, yes.
Yeah, not on this computer yet.
So,
Not on this one.
not on this one.
It's the back
I think if you go into the software center.
I think so.
See there, if
Yeah.
you see the software center, it's the bottom icon. We go
This
below
one?
it.
You
Just
go
like
in
this,
there?
Yeah, and then top left corner.
Okay, so you can.
Yes, you have to. I think they didn't have the time to go through all computers.
Okay.
So here you can find it and install it. Here, this icon here. Did you find it?
It could be on the
Trying to record for George because he cannot make it, so
Yes,
I'm doing the recording.
that's fine.
Oh, should be a That's Zoom one.
No, if it's not there, we have it. The only thing you can find is here. Refresh it somewhere. Updates here. Oh, sometimes it doesn't see it.
Then you need the power as well.
Maybe they didn't put it on every computer. Because I asked for 15. How many are you? 6, 7, 8. So there should be enough. But there are more computers than 15. So let's.
But you can take from this one. You have not that.
So if you can't find it, try to take another computer. If it's not there.
I think it's on your computer, that's not up.
This you have there? So it's kind of weird, it's missing there in the middle. Maybe it's a mistake. You will be seeing that over there. Oh, yeah. Yeah.
Isn't power, take no power.
Okay. Maybe this one.
It doesn't have mouse.
Interesting. I'll go here. Let's have a look. Now I can see Alexis screen.
Technology.
Also we can check the yeah, we can
Oh, you have some Simulink there already.
This one and also this one.
This is too far away, my map is about. So this one.
Just see this one.
This one would be possible, maybe. They
Let's have a
get that power.
Maybe it's easier if it's closer. Yeah.
Did you find it? Oh, very good. And some computers are still installing, I see.
Yeah, exactly. I might have to go backwards.
Says that the firewall blocks some features, but I guess it's not important.
Probably not. We are going to use the very basic.
Okay, so it's like.
I think yes. Tomorrow morning you can do as you wish. You can come to the presentations at 10 o'clock, and if you wish you can come to 9 o'clock when I'll be here and help you with the calculations, assignments and so on.
But can we focus on the quiz stuff for that, please? You know, for the assignments, can we, in the tutorial tomorrow, can we consider
Giving some examples.
Yeah.
Okay.
Yeah.
Yeah.
Because that's the main area of interest.
Okay.
You know, perfect.
But you have also to remember the quiz. It's also a very small part of the whole course.
Yeah.
So don't get stressed up about it.
Yeah.
It's,
Yeah.
Too late.
It's a good way of relieving that stress tomorrow.
Well, it's not a small part, it's only 4%.
Yeah.
And if you get low points in the test, it doesn't mean that you fail the course immediately. That's not the point. But it's a way to get you to study words and understand what is a controller, what is the P action, what is the integrator, things like that. So that's why I want to have the test, so I be sure to get you to.
I was really making a mistake.
Can you do it again if you fail on calculation?
We'll do something, yes. I will not fail you in the course. You will get a second chance somehow.
Yeah, exactly.
I don't know if it will be taking the test again or doing something else. But of course we do.
The other quiz I don't worry about calculation. Too long time since I started studying mathematics.
Yeah.
Still a simulated. Still a simulated, so it's not
Must be the same way.
So let's see, I'm still waiting for. You got it up, you have it here, and you, yes, you have it, and you have it. And here it is. Yes, I think everybody's ready. So, let's see. Oh, you are not. How did I miss you? But as soon as you can say, as soon as that's been. What I thought we do together today to get familiar with how it works, we will think about an autonomous car. It's easier to simulate cars because you know the vessels, they are in water, they are this slow. So for this example, I have chosen a car, autonomous car. The car is driving, and it has two lanes to drive in, the right lane and the left lane. And the desired speed of the car is 70 kilometers per hour. And if there's heavy traffic in the lane it's driving, then it will check if it can move. If the left lane is free, then it will move over there and continue driving. So every time the lane is busy, it will check the other lane and move to the other one. If both lanes are having heavy traffic and are busy, it will just continue driving. It's kind of a very easy but that we will build up to simulate. So did you get the point? An autonomous car driving, we want to drive at 70 kilometers per hour, and it has to choose in which lane it will be driving. So that's the goal for this little example. So this is not an example you have to hand in or anything like that. It's just for us to training on the program. So this is the MATLAB interface that we have open here. And if you are doing calculations here in MATLAB, it's command-based. You just enter here what you want to calculate. If you want to calculate the root of some equations, there are functions to use. But we are going directly to the simulation stuff. This is a really nice addition toolbox to the MATLAB that allows us to do it more visually. It's easier to get boxes and drag and connect them than to write a code and doing it by commands. So Simulink icon we have here. So you just double click on that one and then you get a window like this. And because I can't see where you are, if you fall behind or don't understand, please ask and stop me so I don't go too fast. We are going to start now with a new blank model. If we want to continue on some work we have done earlier, we can find them here in open or resend. But now we are going to choose here the blank model and open it up. Then you get a window here where we are going to build our model. So we are actually in no need for this MATLAB window. Now we are going to work here in the Simulink toolbox. We could start by saving this. If we will not get finished this morning, we will continue it on Friday. So just save as and save it somewhere that you can get it tomorrow if we will continue with it. I think we will get it finished, but just in case.
Question.
Yeah.
Can I save it on the storage and USB thing?
Yes, but that's not. You can do that, but then it will be working from the storage bin, and that will probably, because it's creating a lot of temporary files, it will. Yes, so better to, but you can put it, for example, you all should have an own place here under this PC. You could find your name. That's your storage place on Novia. And this storage place you can get to from every computer in Novia. And of course from home, if you are using the program files, you can get to it. This is a storage place. So you can put it, for example, there. And you should all have it. So let's call it. And you see the Simulink files have the ending SLX. And then save. You can save to this PC. I didn't choose it. So, okay, so now it's saved. If something happens. Okay, then we have the icons, the tools we have here under the Tools drop-down menu. Here you find Library Browser. So you open that one. It's nice to have a big screen. So here's a lot of elements you can use when you are building systems. We are going to do this task with if blocks. There is an easier way to build it, but we learn more by using if blocks for this task, because we have to check the traffic, and that if statements are good for that to check that is it not. So from the ports and subsystems, you can find it here. I'm sorry, but this is kind of small. I don't know. I don't think they will get. They will get a little bit bigger, but still kind of small. But do you see enough? Ports and subsystems. You open that one, and from there we are going to choose an if block. Here we have a common if block, and you just drag it here to your simulation. Let's see if we can get this one a little bit bigger too. Works like that. Okay. And when we are on it, we are going to take if action subset block. It should be, it's here to the right. If action subsystem, not subset, if action subsystem. So you drag it also into there. Okay. Will we all with me? Yes. Then you double click on the if block here. We are going to enter some settings. We will have two inputs to the if block. So number of inputs 2. The if block, the idea of this one is that it will check if the car can drive in the current lane, and it will also check if it can drive in the other lane. So this block is doing the checking of where to drive. Okay, so now it has 2 inputs.
And that's all. You don't need to do anything with the overview.
Not yet.
Oh.
Yeah, I will do it later when you better understand what we are doing.
And you have to apply that to. You have to apply as well, or just okay?
I just okay. I just pressed. Yeah. I think apply will also it will change the thing, but it will not close the box. So then we go to logic and bit operators. You have here a library of that, and from here we take a compare to constant block. It looks like this. And we drag it in.
What about the constant value?
The constant value here, we want to put our desired speed. So we put 70. So instead of 3, we enter 70 here. And we don't want to have it less than or equal to 70. We put it as greater than and equal to 70. Because we want to drive at least 70. So here we change the operator to greater than and equal, and the constant value to 70.
And it's a boolean,
Yeah.
so it will come out as true or false.
Because the if block we have here, it wants boolean.
Oh.
It wants a boolean logic. And then okay. So now we have a constant block. And then we can connect it here to the if block. When you connect blocks, you just take with your mouse here in the first one and drag it there to the first input there, like that. And you can always move these around to get them nice. If you want to move several blocks, you can choose them like this and then move the whole thing if you like.
Kathy, do you have Skype on there because I'm having difficulty connecting Maya to this one doesn't even have a camera. I know I'm trying to even it won't let me share the desktop whether
I'm also recording, so I will upload the video somewhere on YouTube or something. Yeah, so for George and Maya, so they can.
well, actually, that she sent her personal. So see if you can see her. Oh, cool. Thanks, John.
We need a couple of more of these if action subsystems because we have different outputs here and we will do different actions regarding on our output. So we will copy this block. So we got 2 more and that's just, for example, copy and paste. Another way to do it, of course, is to drag 2 more, but it's probably faster to just copy them. So we have 3 different actions. One action is that the current lane we are driving in is good. We just continue there. Another scenario is when the current lane is bad, but the joining lane is good. We can do it over there. And the third scenario is that both lanes are bad. We just have to keep driving where we are. So we can give more suitable names to these blocks. If we call the first one, you can change the name here. It doesn't have to be called if action subsystem. We can call it this first one, current lane good. And this middle one we call current lane bad, adjoining lane good. Current lane bad, adjoining lane good. And the third scenario was that both lanes are bad. Then I would say something happens. Right, so now we have three cases. Current lane good, current lane bad, adjoining lane good, and both lanes are bad. Okay? Then we are going back to the if block here and do the settings. So we double click on the if block here again. And now when we have changed this number of inputs to 2, we have 2 possibilities here to enter our expressions. So the first expression is that the input signal here that is desired to be 70, that the lane is free. We change it to if the first signal U1 is not equal to 0. Not you can get from alt great, and it looks like that, like a little wave. Alt great, and there to the right of the keyboard, just the left of enter. And that means not equal. Yeah. It should be there, you can see it. And then when you press equal sign, you get it. It doesn't show up immediately when you press Alt Great and that bottom, but then when you enter the equal sign, you will get it.
Can you type in on the digits on? Yeah. Can you type in the where it is?
There it is.
There it is.
And then you press you have Alt Great here.
Yeah.
This one and that one, and then the equal sign is there.
No,
okay, I think these are in the wrong place. Just next to the
yeah, that's why I was confused. But okay, I'll work.
So here it's the other way around.
Yeah.
Yeah, the D is wrong.
Yeah.
So that's
look here. That's the typical one.
Yes. So this is a default keyboard. A defective keyboard.
Yeah.
For sure. So did you all get it? Not equal?
Yes.
Fine. Good. So when it's not equal to
both
0,
control
and here we check if the second signal is not equal to 1.
Is there no space allowed between those signs or digits, or does it matter?
I don't think it matters, but I have to.
I think it matters.
Ah, I need to test it right away.
It matters.
didn't
Yeah, but in the
compare.
example there is space. If you see.
For that I'm not sure. I would guess it shouldn't matter, but
Because they want
let's be safe.
Let's see.
I don't know, maybe it is broken. Just ignore that.
So the first one not equal 0 and the second one not equal 1.
What does that mean for us?
That means because this is a Boolean, it just checks if it's greater than 70 or not. And if it is, you get out a 0 or 1, and you are just comparing. If you get out a 0 or not, then you can take further action. Okay, then now we have here in our if block, we have 3 outputs now. So now we connect each output to the top of each one of the subsystems. So we take the first output and put it in the first output. And the second one there, and the third one there. And if we would have our if block here in a different way, we, for example, first check if the output is a 1, and then if it's a 0, then we have to connect this the other way around. Okay, then
So
we
do you have time to come here because there's something wrong with this one. Doesn't allow me to. Is that correct now? And that one too? Because it says that it does not. Yes, question.
U1, U2.
Okay.
You have to be this, yes. It became illogical then.
Yep, that's why.
Yes, and then we can continue.
Yep.
We'll wait. So now I think you have it looking like this. You have connected the boxes. Then we need a signal to the system. We need some input, and in Simulink we just generate them with different blocks. We can find signals in sources. Here we have sources in the library. And for this one, it's convenient to use a signal builder block. You see here a lot of different inputs regarding on what we want to test. When we are testing a controller, as Jari told you, we are very often using a step change, and there is, for example, a block for a step change when you are wanting to test your controller. This one is what you are going to use in your laboratory assignment. But now we want signal builder. We take this one. Okay. So we open that one. And we need two inputs here to our if. Our if statement here wants to know what the current speed is, and it wants to know about the other lane, is it vacant or not. So we need two signals to enter to our system. So we choose here signal and new, and we need a pause. We want a signal that changes. So now we have two here. One of these is for the desired speed, and the second one here is for the lanes, are they vacant or not.
Sorry, how did you get the second signal?
Here, signal here, and then new and pause. First, we start putting them in the default position. If the lane is vacant, it's 0, so this is already at the default. But our speed, the default speed when we start is 70. So we should change this signal 1 here to 70. We click here at the start and click again so that you get these activated. So here at time 0, you want to enter 70 and enter. So then it goes up here to 70. And because we had two different...
Could you please show again how to...
get this up here?
Yes, how to change to 70 time.
It was here, so
yes.
you click here.
Yes.
And you get a little round here.
Yes.
And if this knob went activated, you click again. This should be alive. And then you can here write 70.
Okay. Yes.
Good. And then it jumps up there. So we want to test all the situations. So we are going to modify this pause so that we drop down the speed to 60 and then up again. And here we are going to, at different times as here, we are going to make it busy, so we have to change lane just to test the simulation. So, for example, we will say that at 4 seconds here, the speed will drop down to 60, and this is a little bit, we need to click here and try to drag it up a little bit so you get it to move. So if you click here and drag a bit, you should get it to, did it work for you? Sometimes it just pulls that one up, but that's not what we wanted to do. So, in the first 4 seconds, the car will happily be driving at 70. So, we take that lower. Here, at 4 seconds, we will put it up to 70 again. So it goes like that.
I can't seem to move it moves the entire one.
Yes, that's...
Is it double clicking on it?
I sometimes use click and then, it's annoying, yes, when they are, yes, it's going now all the way. Try to click somewhere else in between, so I try because I sometimes have a problem with that too.
Okay. Okay, but I need to get this one up.
Yeah, you need to get that so that it divides it, not...
Okay, I should get it.
Maybe you should try the other signal. I don't know why it sometimes does that.
Okay.
If you click and then click again. Okay, let's take some other point. Take this one so maybe it's okay. Try that one.
Okay, one click.
And then put it up.
Okay.
That works. Okay. No, try to get the other one.
One click.
You can try to put it down or you should try to get the same thing.
Yeah, exactly. Okay, I will try.
Yeah.
So I need to move it up a little bit.
Yeah.
So to 70.
Yeah. But it's really interesting that
It gets stuck.
yeah, maybe if you try to click on it and set it to 0 and then try again. Click again and now it's 0 again.
This one.
And
No,
now
the
that
other
should be
one.
4
Four.
and that's to 0. And enter. And then we try again. No, it's really annoying.
Yes. Okay, let's not get stuck. I will try it.
Yeah. I have had the same troubles. Once I got furious, I killed the signal and started again, then it was fine.
Okay.
This one worked nice.
Yeah, the other one works. Yes.
Well,
One cannot zoom in. Why can we not zoom in? Choose which one we want to use that.
I don't know. Well, no.
I tried that with
You
the
do, okay.
But maybe if you put it in maximize, maybe it can work.
Maximize, yeah.
Ah. Because this is really, that's, I don't know what it does when it started getting problem, it's really troublesome. Well, we continue working. This second point, we want to put to 60. The speed is 60. So click on that point and enter here 60. And that means that we are driving too slow. And the same thing here at 6 seconds. I see it works fine when I just click on the point and drag it. I don't do click and click. I just click it and drag it immediately.
Yeah, it seems I got the signal 3 and then it works perfectly.
Okay.
On the 1, I don't know why it's stuck. Can I use maybe signal 2 and 3 or?
Yes, it does, yeah.
So you can either enter to the table or drag the curve to the correct position.
I drag it. I click and drag it, yes.
Yeah, but can't you just drag the curve to the right position?
But I need it to get like this, that is, it's the same. If I just drag it, it will go up the whole thing.
Okay.
Now, this point here, we want to be at 60 because from 4 seconds to 6 seconds, we want it to be 60. So we click on that point again and put 60 here. And this lower point, we want to 70. So click on that one and write 70. And this last point to 70 also. And then we get something like that.
Okay, so I got it working now, but
Take the lower ones and pull drag it. Ota se alempana vasemmanpuolisena alas.
Yeah, and that to 70.
okay.
Se vaan ylös.
It's easier that we write.
Pitääkö kirjoittaa?
This one is
And that's this one to 70.
And this one to 60.
Yes.
Okay. So this one is 60 and all.
Yeah.
change the left point.
And the same thing on the other side.
Yes, to 60 and then up to 70.
Can you
I drag.
Yeah, that's fine. As long as to get it them to be first 4 seconds 70, then it comes down to 60 for 2 seconds, and then it goes up again. That's
So
The same thing on the other side here.
Yeah. Yes. Well, good.
can
Then
you
we start
tell the values again, because mine looks a little bit different.
Okay.
So the first one was 60, and the second one.
This to 60, and this one should be vice versa. This should be 70 and this 60.
Okay.
So this should be 60.
Yep. It's better that you move the other one first,
Yes.
because they will be on each other.
That is
And
60
this one.
way. The next slide should be 70. So if you click on that point, just drag it a little bit up, like this. Then you can click on the
Because
line.
now you have only 1 point.
Yes.
Then you can set
Can you,
70 and 70.
if you now draw,
The entire line.
if you can you undo
So
to
you're setting
the
those
point where
points
you had 2
instead of
points?
dragging it.
Yeah.
So I'm not sure if it's a
Okay, you cannot.
It's awful.
Okay,
When it works.
Well, it works, thank you.
now we have to try. Okay, good.
Yes.
Now you take that one and put to 70. And then those 2 to 60. Good. Alright, then the second one. We need to change the time a little bit. So we change this so after 3 seconds, this lane will become busy. So change this point to at 3 seconds be 1. Because now here the lane is vacant, and then it will be changed to busy. At that point, at time 3, it will be 1. Oh, now then it won't work like that.
So we have 1 equals busy, or
Yes. Now I destroyed that one. I'm really not a fan of the signal filter.
what was the first one on that signal too? The first one is.
This should be at between 0 and 3, it's 0.
Okay.
And then at 3 seconds it changes to busy to 1. And between 3 and 5 we will have it to 1, and then goes back again.
You need to change the Y.
Can I say again? So between 0 and 3.
I write it down.
Okay.
So between 0 to 3 is 0, and from 3 to 5 it will be 1, and from 5 to 10 it will be 0 again. So the lane will become busy, and then it will free up again.
So if you just click and set that, or you can try to follow it. Just so 0 is flat. You might have to try
So kind of like this, I let you work with it. And of course this signal we could go on and on and on. This is just 10 seconds.
I am unable
So
to.
I think this is only like a.
So at 3,
Yes, now you move this one, for example, to 3. You click that one and you can write here 3 and 1. Now it's set. There 1 and the 4 you change it to 3. So, now it went right. Okay, now we have to put it down to 0 first. This is kind of annoying. You click and okay, let's see. Now try to. No, you can't put it up. Click somewhere else so we get away from the point. Now click and drag. No, it didn't work. Because we need it to split again, you know, like this.
that's what I was trying to.
Yeah. If we start with this one, will you move that right there? 5. Okay. And that should be 5 also. So we have 1. Okay, 1 is okay. Now we just need to get those separated. No, it didn't work. Oh, yes, good.
So this one.
First change that one first. Otherwise it won't. So that should be 3 and 1. Here, 1. Now it's close.
And this one should be
To 0, yes. It's always better to write you get it exact, but it's not so. So, good. Now you have a good signal. What happens if you take here and pull up? You just pull up. Now I find a nice solution. When they are really getting trouble to get them up, just take here on the line somewhere and pull it. Then it will separate. So that was the easy way to do it. So you don't have to try to get the point. So just if you move it like this, then it will get separated. Okay. So now we have a scenario where the lane will get busy after 3 seconds, and after 5 seconds it will be free, and where the car is driving, the lane, it will drop the speed because here its lane is busy, and then it goes up. So this is the scenario we are going to simulate. Has everyone got this correctly? All right. Then we continue. Now we have the signal. Okay. We can close this one. Now it's down here. So now we take.
We don't need to save it.
It will be saved when you click. You just close it. But then the whole Simulink file here, you always save here by the diskette there. So. Oh, don't die. No. So the first signal here, the signal 1, that was in our case we put our speed. So the speed we drag here into the compared to constant block, like that. And the second signal should go here into our if block. Let's see if I can get this a little bigger. And I drag it in there. These boxes you can always make different sizes so you get nice straight lanes if you want. Okay. because this if wants Boolean as our compared to constant gives us. But this signal builder, that gives double-digit format out here. So we need to convert this signal to a Boolean. And we find that in, for example here, commonly used blocks in the library. You click on that one. And here is a block data type conversion. So you drag that one. And we want the output to be Boolean. You can write it here, or you can go into the box and choose it here, output data type. Here are the possibilities you can convert it to. And we want it to convert it to Boolean. And then we click OK. And this signal we want to convert, so we can just put it up here. It should connect itself if we put it here on the right place. Yes. Here you can find all different types to convert to. And then just wait.
Sorry, where can we click on? Oh, it's here, yeah.
Yes, yeah, good, yeah.
Can I say again, why do you read this?
Because this if block always wants a Boolean signal inside, into it. And the signal, it always gives out the number in a format of double digits. We have double digits, we have double, there are different formats to give a number in. So we have to convert it to the right. It's like the one box is speaking French and the other one is speaking German.
I understand.
The whole thing, yeah. You can just with your mouse, you can select everything. You click there and then you just use, yeah, just like that. And now you can, everything moves when you have to take it to the box. So you select it and then pick a box. And now everything moves. Alright. So now we have a signal into the system. And you all got it to nicely connect when you drag the box on it. If it doesn't work, you can just kill the line and drag new ones. If it won't nicely go on there. Okay. Now we want a merge block because the signals that comes from our if action subset, we want to merge into one signal. So under signal routing here in the library, we find a merge block, very commonly used block in Simulink. So we drag this one here. And number of inputs we need is 3 because we have three different cases here. So you can either write 3 here directly and put OFO, or when you double click on the box, you get here number of inputs, and here you can write how many. Then what we get out from from our simulation, we want to, of course, plot to see what will happen. And to see Simulink results, we often use a scope. And a scope we can also find under commonly used blocks. It's so used. I think it's also here under sinks, because sinks are output blocks, sources are input blocks. So a scope. But a scope is very, very common, so you can also find it here under commonly used blocks. Here are the most used. So we need scope. Drag it here. Number of input ports, we have just one, so that's fine. So the scope block that will indicate in which lane the car should be. If it draws, if we get out here 1, it should be in the right lane, and 2, it's in the left lane. Okay. Now we go here to the first. You all did get the merge and the scope here. Yes, good. We can, of course, connect them here right away. The output here will go to the scope. Let's start with the first, the current lane good substitute system here. You double click on it, then it opens up. You double click on the first system. And now it just goes the signal 1, 1 through here. But we remove this input, we put a constant instead. So you can delete this input here. You just choose that delete it. And we enter a constant instead. You can find here. And you drag it there. So that it connects. One means the right lane. So here we get out 1. We need a similar system in the second subset, so you can copy this by, not that you need to copy these 2 boxes and the line like this. You can just select so that you get selected the box, the line and the output, and you copy it. Control C. To get out from a subset, you don't click here, then you close the whole Simulink. You just click, you see here, we have the name of our simulation file, and now we are here in the subset currently good. So if you click here on car simulation, or what you called it, you click there, then you get back to the system. And go into the second system by double clicking and copy here in what you just paste in here, what you just copied. And you can get rid of that old 1, like that. And here, the constant should be 2, as for the left lane. So you change the 1 to 2. So this looks very similar as the first subset, but now we have constant 2 that goes out. So this indicates the first, the second, the left lane.
I cannot go.
The first one.
Control-undo is Control-Z.
Oh, Z.
Yes, Control-Z, yes. Control-C for copy control.
Yeah.
Control-Z, yes.
But why constant? Was already.
It's for the left lane. 1 is right lane and 2 is left lane. So we have then the merge that will, when we are combining those, we will get out either a 0 or 1. So it's no.
Got it. Let's do that. So this is the first one. I copied that.
Yes. But no, you have this one. You need to copy, so that one just come with you.
Everything comes with.
No, you don't want that one. Yes. Maybe if you move it a little bit down or something.
This one.
That's the way to do it.
No, it's almost way.
No, it works. Yes.
So we took that one as well. So that was me.
That was the problem. Yes.
So then just
Yes.
paste here
Yeah.
and get rid of that.
Yes.
Yeah.
And then this should
Thank
be
you.
a 2.
Yeah.
It just try to drag from there. You can put it a little bit. It just.
I didn't notice it actually. I took everything.
No, it just broke for a while.
And concentrate the last one then?
No, that will be different.
Okay.
What is going to happen in the third case when both?
We are going there. It will be different.
Okay.
So now we have the 2 subsystems, the constant 1, that is for the right lane, and the constant 2, that's for the left lane. And then we go to the subset 3, that will be a little bit different. Because from the subset 3, we will, where both lanes are bad, we will connect this signal back in there. To get a signal to divide, so we can get a signal from it, you need to hold down Control, the Control key, and then when you click here on the signal, you get it to split like this, and then you can drag it in here to the third one, like that. So Control is the key to get a connection like this, a split like that. So, here in the last subset, the point is that we want it to stay in whichever line it is, because their traffic is heavy and slow in both lanes, and it cannot drive at its desired speed in either of the lines. So for that one, we want a feedback signal from the merge block.
How do you give yourself an input for that?
This line, you held down the Control key.
Yeah, no, I brought the line around, but it doesn't actually have an input, it only has a...
Here.
Yes.
So you have deleted.
Yes, yeah.
Yeah, somebody's got a wrong line, lights turn red.
Then just try to connect them again. But if you don't have this in and that there, you can maybe take a new if subset. You can take a new box.
Start again.
Yeah. Because now we have deleted all
Yeah.
but here is an in.
It didn't take anything in.
Here you can find it. There is an in
Oh, yeah.
in the command.
No, you just leave that.
So what kind of feedback is it?
Is it different from one?
Here's the feedback that where it is, we get the same number in here. That means that stay where you are.
So it doesn't move at all?
No.
Okay,
Both line
stop.
planes are busy, so it just continue driving.
Okay, but what would be the speed of the driver?
It will go as fast as it can. It will check. It will not go too near to the.
So using some
Yes, we need a more complex system.
yeah, adaptive cruise or
Yeah.
okay.
Yes. Because we have here in the signal, we have here put that it will drive at 60.
Okay.
We have entered that. So of course this signal now we manufacture it. In real life we measure it.
Yeah.
Okay, these outputs from the if action subset should go into the merge.
Yeah, I need to go
Yeah.
mine's done a little bit awry.
These will go in here on the top.
Yeah.
In there. That will work.
So it is not connect.
Yeah, because there are no inputs to put them.
Yeah. Okay.
And this one also should go to the top. I think you need to delete it because it's stuck. You press it and delete. Oh, now you better redo this. And now this one in there. Yes. And now put these three outputs here into the merge block. Like that. Okay. Now I have created something like an algebraic loop, and that's not good. Because the signal that comes here goes out here and goes back in. And that means that at the current, at the same time, I want an input here and an input there from the same time, and that's not possible. So we need to put a little delay here so that it doesn't go immediately in there, because we can't have the same time out and in a block, because there's always a delay when we are measure some things.
So how can you put it in real world scenario, like in case if both lanes are busy? So
well, in the real world there is a delay.
yes.
It's there for real. You don't get the signal right away in when you are.
But in like bigger traffics, when the lanes are always busy, what will happen?
It will just stay there where it is and drive at 20 kilometers an hour. So we need a delay so that it doesn't have the same time here and here. That's an algebraic loop, and that's bad because the current time is dependent on both the input and the output. So we put a delay in. That just fixes the problem. We can find the delay here in discrete library block here, and we take a unit delay here. Drag it here. Initial condition is 0. We start from 0. So I don't think we have to enter anything, and there should be a 0. This one we now need to put here on this signal, but this block is going the wrong way. Yeah.
What was the initial condition? Was it 0?
0, yes, we're starting at time 0. This is going the wrong way, the block. We need to turn it around 180 degrees. One way to do it is to click on it and put Ctrl R. R is for rotate. 2 times, then it will go around 180 degrees. So now we have the input here and the output here. When it was the other way around, it was the wrong way because this is going in that direction. So now you can connect it there on the line. You just drag it up there, like that. We need to do some modifications here to our model because we have a discrete object here. So we go here to simulation up here. And here we can find model configuration parameters. Click on that one, and a window will open.
I had a question about delay. What is it actually doing?
What the unit delay is doing?
Yes.
It is the signal that this simulation program will put in here. It will delay for a little while, and we will enter for how long? We will just delay it for a tenth of a millisecond.
Oh, okay.
But just that because we can't have the same signal here at the output and the input, it's impossible because it takes time for things to. So we just delay. We can decide for ourselves how long we hold it up.
Oh, okay.
And of course, when you are regulating something, the longer you hold it up, the slower your system will get to react to things. But we need a little delay, otherwise it's not possible in theory. I know in practice, in theory everything is possible. So, here, the type, we have it to a fixed step. We take the easy way. And the solver, here we choose to discrete. No continuous stage, it's just a discrete. So fixed step here for type, discrete for no continuous, and additional options here. We enter how long do we want the delay to be. And we enter 0.10. And I think MATLAB wants it as a point, not a comma. It little bit depends on how the computer is. But at least on my computer at home it wanted a point, a dot. But if it wants a comma instead, it will complain. And then OK. So now we have a delay here of 0.1. All right. So now we are done. Now we have built this kind of easy model. It's not perfect. It's not checking everything an autonomous car should check. but this will simulate the changing of the lane. So now to run the simulation, you have all now the lines connected